All right, everyone. I wanted to give an update on the components I'm using for this little garden monitoring system and controls. So um, let's take a quick look. I've got 3 of the sensors here. So the first is what I'm going to use to measure my water level. Um, this is actually a really simple device, just 2 leads, and it measures continuity from one lead to a next. So this is very versatile. It can be in a normally closed or normally open operation, and you can actually get both effects depending on how you orient the device. Um, but let's take a quick look. If I bring in my multimeter here and I set it to continuity and I connect the leads, whenever current can flow from one lead to the next, the multimeter beeps. So if we look, if I'm going to install this in a top-down fashion with the wires coming up, whenever the water level is up, the float is going to be towards the top and no current flows. When the water level drops, and the float goes down, continuity will flow. So I can measure that by using a simple voltage divider or just a resistor to see when it goes to ground. And I can know when the water drops below a certain level. So I can have this mounted at the very top, so if I get any drop, or I can have it mounted very low towards the bottom of the tank. And whenever it drops, I'll know that it has reached a certain level. So it's really easy. Now, I could get the same operation if I mounted it upside down. So as the water goes up, I get continuity. So in this case, I've got a normally closed or normally open circuit. And when I do this, it closes. I have to actually activate it to close it. If I do it this way, now it's a normally closed circuit and the movement triggers it. So, I can create both, but they've also got it the other way to where if it was up like this, I'd get a open operation. They give you both versions depending on how you're going to mount it in your apparatus. The next device, and so these are ones I've had before, it's the moisture sensor. So these are a very simple design. It just uses a transistor. Let me pointing device. So it just uses a transistor, and that's what that is right there. It's just a simple transistor, and it measures or we get a voltage output, an amplification based on current flowing from here to here. It's pretty simple. So if we look at it, here it is with its connector. I've got some lead wires coming out, that way I can actually measure it. So I'm attached to my power supply. My leads come down. I've got 5 volts coming out to power it. So I'm connected. My power wires, black and red in this case, and then the blue wire is just a voltage output. If I take my digital multimeter and I measure the voltage from here to ground, so I'm connected to it, you can see in this current state, it's basically an open circuit. There's no continuity from one terminal to the next. I get 0 volts output. But if I create some continuity, basically what's happening here is I've provided a different resistance value. And so now it's given an output. So if I take it and I lick one of my fingers and I do it, I get a different voltage output because with my saliva I'm more conductive. If I do the other, I can get an even higher voltage output. So what we're going to do is we're going to test this. This is a highly unscientific test. I've got a dead plant here. it wasn't watered over a summer break and it died and never did anything with it in preparation for this. So if I put it in this extremely dry soil, there is zero moisture content to this soil. It has air dried in a window or sun dried in a window for a long time. So I've got nothing. I'm going to take my bottle of water here and I'm going to water on the other side of the plant because I want moisture to soak through it. So I accidentally got water directly on it, and you can see my voltage jumped up. Now, with this being analog the way it is, the voltage output is going to depend on how much current can flow through the system. So different moisture levels as well as different mineral makeups is going to change the voltage output. Now, I've never gotten it to go much higher than this, even if you put it just directly in water, which so that's just water, and I get almost 3 volts as maximum output. Technically, I should be able to go higher if I short circuit it. And that's basically full output. So short circuit would be bad. We can take that into account and we can monitor. If we ever get full voltage, we know something's most likely failed. But it looks like our scale, because saturation is going to be 3 volts. That's just nothing but water. That would be a bad condition for our plant. We don't want our plant sitting in that. We have to do some experimentation to find out. It's still extremely dry, and I'm getting this value, 1.4 volts. So we have a very narrow window to work in. It's probably about 2 to 2.5 volts. So we have to make sure we plan for that in our circuitry and our coding for the Arduino. And then the last component is my humidity sensor. It's small. We need more light. So you see how small these things are. You can see the center pad there through the punch out hole on the bottom, but there's 4 pads on this. This is not going to be fun to work with, but that's it. At some point I'll have to prototype that. I can't test it here, so I'll have to physically solder on some wires for this sucker to do any testing, but it uses I2C communication, so I've got to have a functioning Arduino Nano 33 before I can get anything done. So that's today's component recap. We'll have to get these plugged into breadboard and some base code installed and start working with these, getting something functioning.